Hi everyone, welcome to my YouTube channel. This is Dr. Deepthi Prakash from the Department of Electronics and Communication Engineering. In this video, I'm going to discuss about basic electronics subject. In this basic electronics subject, this video is all about the module 2, which is of the transistors. And here in this particular video, I'm going to discuss about one of the transistor, that is Bipolar Junction Transistor, BJT. This video is all about the important questions and the answers I'll be discussing. These important questions which might be appearing for the exams as well as for any of the test, which will be important in this particular BJT topic. So here we go. Let's start. Which are the important questions regarding the bipolar junction transistors? So before going to the important questions, let's have a brief introduction about the bipolar junction transistor. This bipolar junction transistor, or a transistor, is an electronic component which is used to transfer a signal from low resistance region to high resistance region or vice versa. So this we name it as transistor. So you can see here, transistor is nothing but transfer resistor. So it is transistor. So it transfers the resistance or a signal from low resistance region to high resistance region or vice versa. So this transistor is a semiconductor component which is used in the electronic circuits. It is a semiconductor device. It is basically of two types, that is, so it will be basically of two types, that is bipolar junction transistors and field effect transistors. So in this particular video, we'll be concentrating on bipolar junction transistors, and in my further videos, I'll be discussing about the FET also, that is field effect transistors. So here the BJT, as I told, it is a 3-terminal semiconductor device. So this 3-terminal semiconductor device the 3 terminals are base, collector and emitter. Here the base will be very lightly doped compared to collector and emitter. Collector and emitter will be heavily doped. And why this name of the 3 terminals as base, collector and emitter is, the emitter is heavily doped and its main function is to supply the charge carriers. That means it emits the charge carriers to the base, and the base, which is very lightly doped, which is the middle section of the transistor, is very thin. It will pass the emitted electrons from the emitter through the collector. The collector's main function is to collect the majority carriers, charge carriers, from the emitter which has been emitted through the base. So this is the basic construction of the BJT, base, collector and emitter. And we also call this BJT as current control device. Why it is named as current control devices? A small base current which will be flowing through this base terminal controls the current flow from emitter to collector. So as the small base current controls the current flow from emitter to collector, we name this BJT as collector controlled device. And in BJT, the current flow is due to both the majority carriers and minority charge carriers, hence the name the bipolar. And also this BJT will have the two junctions, and these are some of the commercial transistor which we use in our laboratories and in any of the devices, electronic devices. And this is, in the BJT we have two types of transistor, that is based on the construction type, that is NPN transistor and PNP transistor. If NP type is sandwiched between two N types, we name it as NPN transistor, and N type will be a collector, N type will be emitter, P type will be base. And it will have the two junction, collector base junction and emitter base junction. Similarly, in the P type, N type will be sandwiched between two P type. P type is collector and emitter, and N type will be base. There are also two junctions. So this is PNP transistor, and this is nothing but the symbol which we use in our electronic circuits, the symbol which represents the transistor. This is NPN transistor, the arrow mark which is pointing outwards, this is NPN, and the arrow mark which is pointing inwards, this is PNP. This is the direction of the flow of electrons. So this is regarding the symbol and the construction. Next, we'll be discussing the first important question of this BJT topic, that is, they'll ask, explain the operation of BJT NPN transistor. So how we are going to explain the operation of BJT NPN transistor. Then you might also have one more question, that is the operation of BJT PNP transistor also. So what is this is, this diagram represents the unbiased NPN transistor. Unbiased in the sense without any battery or without any supply. This is the diagram of the unbiased NPN transistors. So in this, what happens, the depletion region penetrates more deeply. The depletion region penetrates more deeply into the lightly doped side, that is P type. So in order to include an equal number of impurity atoms in the each side of the junction. So the depletion region at emitter junction penetrates less in the heavily doped and extends more in the base. And less in the emitter side. Similarly, depletion region at collector junction penetrates less in the heavily doped collector and it penetrates more in the base region, that is P type. Since collector is slightly less doped than the emitter, the depletion layer width at the collector junction is more. Depletion layer width at the collector junction is more than the emitter junction. So this is regarding your unbiased. And the barrier potential or the barrier voltages, it will be positive on the N side and it will be negative on the P side. Here also it is negative on the P side and positive on the N side. Now if you give biasing, that is nothing but if you supply the voltage or if you connect the external voltage for a transistor. So how this transistor will operate? So how it operates, let's discuss that. So as we know, the base region is narrower and it is lightly doped compared to the outer layers, that is collector and emitter. So emitter and collector will be heavily doped than the base, so that depletion regions penetrate deep into the base region. So you can see here, depletion regions penetrate deep into the base regions. The barrier potentials will be positive on emitter and collector side and negative on the base region. For normal operation, the base emitter junction is forward biased. The base emitter junction is forward bias. This junction is forward bias. And the collector base junction is reverse biased. So this is for the normal operation. So what happens? The forward bias of base emitter junction reduces the barrier potential and causes electrons to flow from the N-type emitter to the P-type base. Okay, so from N-type emitter to P-type base. This is with respect to forward bias. Then the electrons which are emitted into the base region, hence this being emitted as emitter region. Then this is in the forward bias condition. Then the reverse bias at the collector and base junction causes this depletion region to penetrate deeper into the base. This depletion region to penetrate deeper into the base, and the electrons crossing from emitter to base, arrive quietly close to the larger barrier voltage at the CB depletion region. Okay. Since electrons are negatively charged, they are drawn across CB junction by this bias voltage. So electrons are said to be collected in this collector region. Hence the name collector is kept for this particular region. Next, a small percentage of charge carriers entering the base. Small percentage of charge carriers entering the base from emitter do not reach the collector but flow outwards through the base. However, this number is very small because the path from base emitter junction to the collector base junction depletion region is much shorter than that of the base region. So there will be small number of electrons flowing out of this base region, which will be crossing this base region. So this is how you have to explain the BJT operation of NPN transistor. I hope this is clear for everyone. The same thing I have written for your reference, how this operation you have to explain.